Hello students, you are welcome to the GMAT 41's physics class. In our previous class, we introduced one quantity being discussed under motion, that is speed. You would recall that we defined speed as the rate of change of distance, and the unit of speed, SI unit of speed, is meters per second. We also solved a question on it. In this video, I'll be teaching you about velocity, another important quantity of interest when talking about motion. Here we have three definitions on the board here. We're going to talk about three forms of velocity. One, the average velocity. We're going to define the uniform velocity, and we'll also define another velocity called the instantaneous velocity. What is average velocity, V? It is defined as the rate of change of displacement. Change of what? Displacement. The rate of change of displacement. Let me underline this and then I want to explain something quickly. The rate of change of displacement is what we call average velocity. Why did I emphasize, why did I stress this change of displacement? Very important, because if you look at this definition, it is much similar to the definition of speed. The only difference is that speed talks about rate of change of distance, while velocity defines the rate of change of displacement. Remember, distance and displacement are not exactly the same thing. I've already explained the difference between distance and displacement in our past classes, okay? But just as a quick reminder, now if I start a movement from here and I move this way, come this way, go this way, go this way, I've taken different parts. Is that not so? Now the distance is the addition of the length of all those parts. But my displacement is simply the distance between my starting point here, where this blue marker is, and my end point, where this black marker is. So the length from here to here gives us what? Displacement. But distance is all these parts you took, you add them together. So you could see a classical difference between distance and displacement. However, I want to say this. Your first step motion, let's say you move from here to here. At that point, the value of distance and displacement are usually the same. That is why sometimes in the study of physics, especially at this level, sometimes we like use the word, we misplace or misuse, speed and velocity. Because just your first time motion, like if I stay here and then I move like this, my distance covered and my displacement covered are the same thing. But by the time you take different steps of motion, then you would see clearly the difference between distance and what? Displacement, just like I explained already. However, another classical difference between distance and displacement is that distance is a scalar quantity, just a number. It only has value, it does not have direction. But displacement is a vector quantity. It has value, it has size, it also has what? Direction. You can replay what I just said now, trying to still remind you the difference between distance and displacement and make a short note of them. Alright, let us move on. What is the formula for average velocity? Velocity, following this definition, has the formula displacement over time. That is elapsed time, the time taken, okay? When you get elapsed, that is the time taken, elapsed time. Our displacement, we are using change in x. This triangular sign is delta x, which means change in x. That x there is position. Now look at me here, this is my position. If I move from here to here, I've changed position. And now we can talk about displacement. That English word, to displace, means to move from one place to another. So this x here represents position. Delta here is change. So change in position divided by the elapsed time, change in time. Now, using what I used in representing these quantities, if you come here, you have that the average velocity or velocity is simply equal to delta x over delta t. That's change in x over change in t. X is position, like I said. Okay, now if you expand this more, this change in in position, which is displacement, are you following right? Is final position minus initial position. If I move from here to here, my displacement is my final point minus my initial position. And that's what we have here. So x2 here is final position, x1 is initial position. divided by the change in time, final time t2 minus initial time t1. So that is all about the average velocity. I hope it's clear. Alright, now let us move on to uniform velocity. Uniform. When you hear uniform, it's something that does not change. Alright, it's something that is constant. So we can still call it constant velocity. Like in your schools, if you go to school, you have school uniform. Is that not so? You have school uniform in primary school, in secondary school. Now, that uniform is something that is the same. The color is the same for all the students. Is that not true? Alright, so uniform velocity or constant velocity. This is the velocity of an object when equal displacement is covered in equal time interval, no matter how small the time may be. So if you cover the same displacement, let's say from here to here, the displacement is the same as from here to here, the displacement is the same as from here to here. Now if you cover this equal displacement at equal time interval, let's say from here to this first point, you have a time of 1 second, to the other point 2 seconds, to the other point 3 seconds. You see the time is 1 difference. So when you cover equal displacement in equal time interval, no matter how small the time is, that velocity is known as uniform velocity, constant velocity. Because like you saw in my demonstration, there is no change in displacement. The displacements are equal, time, equal. So we say it is uniform, it is constant. The next velocity we are going to define is instantaneous velocity. We use V bracket T for it. What this thing means, velocity that depends on time. Whenever you are talking about motion and you need the details of motion at any particular time, the velocity we use there is instantaneous velocity. Definition. Instantaneous velocity is defined as the velocity of an object at any instant of time, at any particular time. If I ask you what's the velocity of this car moving in 2 seconds, of this car moving in 1 hour, what's the velocity? So at different time, a particular time, I ask you what's the velocity of this thing. That velocity I'm talking about is instantaneous velocity. Once again, the velocity at any particular time. That's the meaning of instant, at any instant, at any particular time. The formula for calculating our instantaneous velocity is given by equation 3 here. Okay, so this will be equation 2. V of t is equal to dx dt. This dx dt means differentiate position with respect to time. In that case, the position function will usually be given to us. You see something like maybe x of t. It will tell you take the position function, maybe something like t squared plus 3t, let's say minus 1. You can say this position x will be given as a function of time. That is, it depends on time. Look at it, x that depends on time. The formula is given as t squared plus 3t minus 1. That is, they gave you this equation to be the equation for position. So what you will do is to differentiate this position equation, this position function. And then whatever time they ask you to calculate this instantaneous velocity, you will now put it inside for, you substitute it for t there. We need the knowledge of differentiation in this case. We will not go too deep in it at this level. Are you getting right? Our focus more will be on this velocity. Take note of this, velocity is a vector quantity, just like displacement is a vector quantity. And speed is a scalar quantity because it's gotten from distance. And we know that distance is a scalar quantity. But both of them have the same unit, meter per second. Let us take questions and then solve on what I've just explained here about velocity. We are going to solve a question here, okay? Now it's about the car. The car is traveling from one town to another one. So let me ask you a question. Have you traveled from one town to another town before? All right, now were you able to check how long it took you, the time it took you to move from one town to another? So if I ask you to tell me your velocity or the velocity of the car for that journey, what would you do? Let us solve this question and see. It reads, a car moves from town P to town Q and the displacement was measured to be 10 kilometers. If it took the car 3 hours for this journey, calculate the car's velocity in A, kilometer per hour, B, meter per second. So there are two questions we're going to solve here, although both of them are still solved the same way. The only difference is that the unit of our answers, A part of the question, the velocity should be in kilometers per hour, and then B part of the question, the velocity should be in meter per hour. Alright, let's see how we solve this question. From the question here, we're going to declare our data. The information given to us, we want to write out the value we know. We're told that the displacement of the car was measured to be 10 kilometers. So displacement, or change in x, is equal to 10 kilometers. Alright? That is to say x2 minus x1. Remember that the car moved from town P, which is the initial position, to town Q, which is the final position or destination of the car. And so there is a change in position. That change in position is giving us the displacement, which is 10 kilometers. Now let us move on. The next data or information given to us is the time it took. That is change in time. Alright, 3 hours. 3 hours. We could say that, okay, the starting time is time 0 when it moved from town Q. When it moved from town P, rather, you know, for a car to move, before moving, you don't start counting time. It's when the car now moves, you start counting. So the initial time, we can take it as 0, and then once you start moving, you start counting the time. So from town P to town Q, the change in time, it took the car 3 hours. Alright, now we are asked to calculate the car's velocity. So a part of the question, velocity in kilometer per hour. Kilometer per hour. Now, when we are asked to calculate velocity in kilometers per hour, what should we know? All we need to do is to look at the question given to us, the data, and then check the units. The unit of displacement here is kilometer. Now, in the velocity we want to get, the unit should carry kilometer, should be a kilometer. Then time is in hours from the question given to us. The unit of velocity in part A of this question should also be a what? Hour. So it means we're going to work with these values directly since they have the units we have here, okay? So I would recall that velocity is equal to change in x over change in what? T. So velocity will now give us the displacement is 10 kilometers. So we have 10 kilometers divided by the time, which is 3 hours. Alright, so if we work on this, our answer will be what? 10 divided by 3 will give us 3.33, you know, and it keeps moving. So this is equal to 3.33. The unit will be kilometers per hour. Why is it kilometers per hour? Agreeing with the units of part A question. This displacement has the unit kilometer, km, on top. Then this time 3 has the unit hours, as given to us in the question. So if you get your answer, kilometer on top, look at it, divided by, which is per, hour under, you have this. So this is our answer in the first part of the question. Now we'll move on to the second part of the question, B. We are asked to calculate the velocity in meter per second. In meter per second. If you look at the displacement given to us, it's in kilometer. So we need to convert from kilo to what? From kilometer to what? Meter. Then hours is time here is in hours. So we need to convert from hours to second so that it will agree with our meter per second. Alright, let's move on. Let's do the conversion straight on. Change in x, which is displacement, 10 kilometer. I explained this to you in our previous class. This 10 kilometers means 10 times kilo times meters. And we know that kilo is 1,000. So this is going to give us 10 times 1,000 meters. If we work on this, our displacement is going to give us 10,000 meters. Alright, so let us look at the next one. Time is in hours. The change in time is 3 hours. So we're going to convert 3 hours to seconds. Now we know that 60 seconds make 1 minute and 60 minutes make 1 hour. So if you multiply this out, 60, you get 3,600. But as a matter of fact, always remember this, 1 hour is equal to 3,600 seconds. So 3 hours will now give you what? Simply multiply 3 hours by 3,600 seconds. And if we work on this, our change in time will give us, let's find out, 0, 0, 18, right, 8, carry 1. Alright, so this is what we're going to get, 10,800 seconds if you multiply 3 by 3,600. Alright, once again we recall our formula. You know that velocity is displacement over time. So our velocity will now give us 10,000 divided by, all right, 10,800. 10,000 divided by 10,800. So what would this give to us? Let's find out. All right, so I'm going to reach out for my calculator. So this is 10,000 divided by 10,800. So what I have here is 0.95. All right, 0.95. 925. So let me approximate it to 0.93, which is now going to be in meter per second. So this is my answer in meters per second. Does that make sense? Now, I could have gotten this answer directly from here if I don't want to do all this conversion. When I got my answer in kilometers per hour, I can change from this kilometer per hour directly to meter per second without doing all these things. Should I tell you how you do that? Now pay attention. You can go for your calculator. Let's do that. What we have here is 3.33 kilometer per hour. The meaning of this is that for every 1 hour, the car will cover a distance of 3.33 kilometers. That's the meaning of that. For every 1 hour, the car will cover 3.33 kilometer distance. So watch, let me show you something. How you work on that now will be 3.33 kilometer, then divided by 1 hour. Divided by 1 hour. So that's what you do. And this means 3.33 times kilometer divided by 1 hour. You know that 1 hour is 3,600 seconds. I know that kilo is 1,000. So this will now become 3.33 times 1,000. Then divided by this 1 hour is the same as 3,600 seconds. I told you every 1 hour is the same as 3,600 seconds. So let us do that and see. 3.33, I'll press it, 3.33 multiplied by 1,000, which is a kilo. Then whatever you get, you divide it by 3,600. Good. So this gave me 0.925, which is approximately 0.93. So you can actually convert directly from here. Let me show you here. Coming down, this is 3. Use black marker. Draw this thing down. That is 3.33. Multiply it by 1,000. Then meter will be left. Divided by 3,600, then second, because we've converted 1 hour to second. So if you press this thing, it will give you 0.925, which I approximated to 0.93 in meters per second. Imagine yourself standing and then you watch cars pass you by, and you decide to just pick out one of the car and then calculate, find out the velocity of the car between 2 times. How would you do that? We have this question on the board that we're going to use to show how we can solve such problem. A car drove past a boy standing and he decided to calculate the car's velocity between 2 seconds and 4 seconds. The car's position from the boy in 2 seconds of his measurement was 5 meters. And in 4 seconds, the position of the car from the boy was measured to be 10 meters. What will be the velocity of the car as calculated by the boy? So let us see how we solve this question. Okay, it's a simple one. We have the 2 times between which the boy wants to calculate the car's velocity. So we're going to take this as our initial time, the small time, okay? So we have that T1 is equal to 2 seconds as given from the question. I'm declaring my data already, you know, as a principle, okay? A way of actually approaching calculation questions. T2, the second time is 4 seconds. So T2 is equal to 4 seconds. Now, the boy measured the position of the car in 2 seconds from himself, and the position of the car was 5 meters. So that means that x1 will be equal to 5 meters. And then in 4 seconds, he still measured the position of the car, and the position of the car was 10 meters. So x2 is equal to 10 meters. It is required for us to calculate the velocity of the car. So we're going to find out what velocity would the boy calculate to be the velocity of the car. Now, we will still recall, as usual, the formula for calculating velocity here when you're talking about different positions. Now, we have the formula to be change in x over what? Change in t. Remember, this change in x over change in t is the same as final position minus initial position divided by final time minus initial time. This is the formula we already wrote, all right, as formula for calculating average velocity. So we are going to substitute now the values we know. So the velocity will now be equal to x2, which is final position, is 10 meters. Okay, 10 meters minus x1, which is initial position, is 5 meters. We're going to divide this by t2, the final time, which is 4 meters, and then t1, the initial time, which is 2 meters. If we work on this, 10 minus 5 will give us 5 divided by what? 2. So what does that tell us? The velocity of the car, which the boy will calculate, to be what? 5 over 2. And 5 over 2 will give us 2.5, right? 2.5. Because 2 can go into 5. How many times? 2 times remainder, that is 2 times remainder 1. 2 times remainder 1. I've used 2 to divide this 5. So if you don't have your calculator, you can work it out by short division. If you have your calculator, just press 5 over 2. Alright, if 2 goes into 5, that will be 2 times. The remainder will be 1. You've divided this. There is no other digit to attach the 1, which is the remainder. So what do you do with that 1 which is remaining? Put your point here. Now that 1 that is remaining, attach 0 to it. If you attach 0 to it, you get 10. Then divide that 10 again by this denominator 2. 10 divided by 2 will give you 5. So the velocity of the car is 2.5 meters per second. And that's the solution to this question. Next, we're going to talk about acceleration and its different forms, just like we just did for velocity.